Hello, in this video we're going to be solving quadratic simultaneous equations. So the objective here is to solve pairs of simultaneous equations where one is linear and the other one is quadratic. So a quick definition before we get started. So quadratic simultaneous equations occur when at least one of the equations contain a square term. So for example, we could have x squared plus y squared equals 34 and y equals x plus 3. So here's an example. We need to solve x squared plus y squared equals 25 and x equals y plus 1. So the way we solve these is a method involving substitution. So you can see that the second equation here says x equals y plus 1. So what we're going to do is replace x in the top equation with y plus 1 because we know that x is equal to y plus 1. So in this case, replacing x with y plus 1, we end up with y plus 1 squared plus y squared equals 25. We can now solve this because we only have one unknown. So if we expand the brackets, so we have y plus 1 times y plus 1 plus y squared equals 25. Expanding these, we end up with y squared plus 1y plus 1y plus 1, and then plus y squared, because we have to include this one too, equals 25. So now I'm going to simplify the left-hand side. So I've got two y squared terms, and then plus 2y plus 1 equals 25. So now this is resembling a quadratic equation, and to solve quadratic equations, they need to be equal to 0. So I'm going to minus 25 from both sides. I end up with 2y squared plus 2y minus 24 equals 0. So what I can do here, because each of the terms are divisible by 2, I can divide each of them by 2. So I end up with y squared plus y minus 12 equals 0. And now to solve this, I simply factorise. So if I factorise y squared plus y minus 12 equals 0, I end up with y plus 4, y minus 3 equals 0. And y is therefore equal to minus 4 and y equals 3. Now, to finish this off, I need to find out what the corresponding x values are. So if I sub them into the second one, so x equals y plus 1, just because that one's a little bit easier, I end up with x equals minus 4 plus 1, so x equals minus 3 for that one. And x equals y plus 1, so x equals 3 plus 1 for this one, so we end up with x equals 4. So now I can write the solutions as coordinates because there are two pairs of solutions. So we can write the first one as minus 3 minus 4 because when we write coordinates we write x first and then y. And then the second one we can write as 4, 3. So that basically means when x is minus 3, y is minus 4, and when x is 4, y is 3. This is the solution, or this is the pair of solutions for this system of quadratic simultaneous equations. So here's another example. So this time we have x squared minus y squared equals 21 and y equals x minus 3. So again, I'm going to replace y with x minus 3. So I'm going to substitute y for x minus 3. So I end up with x squared minus, and then I'm going to write this in brackets just so the minus sign doesn't get lost. So I'm going to write minus x minus 3 squared because I'm replacing this y with x minus 3. And that equals 21. Expanding the bracket, I have x squared minus x squared. So x squared minus x minus 3 times x minus 3 equals 21. Now I'm going to expand the bracket. So I'm going to put this in brackets though, just again, because of the minus sign we need to be careful about. So if I expand the brackets, we have x squared minus 3x plus 9 equals 21. Simplifying that, we have x squared minus 6x plus 9 equals 21. Now, this minus, it's the whole thing, so we're minusing the whole thing. So it's kind of like having an invisible minus 1 there. So if we expand that out, it's x squared minus 1x squared plus 6x minus 9 equals 21. And now simplifying the left-hand sides, we find that the x squared terms cancel. So I end up with 6x minus 9 equals 21. So now I add 9 to both sides, so 6x equals 30, and therefore x equals 5. So this actually only has one pair of solutions, this particular system of quadratic simultaneous equations. When x equals 5, if we sub it into y equals x minus 3, I get 5 minus 3, which is 2. So the one solution to this one is 5, 2. Here's another example. So I have x squared plus y squared equals 25, and this time x plus y equals 7. Now the issue with this one, we can't straight away do what we did before because we don't have x or y as the subject of the second equation. So I'm just going to start off by making x or y the subject. So if I make y the subject, I have y equals 7 minus x. And now I'm going to substitute y for 7 minus x into the top equation. So I end up with x squared plus 7 minus x squared equals 25. Now I'm going to expand the brackets. So 7 minus x times 7 minus x equals 25. So I have x squared plus 49 minus 7x plus x squared equals 25. Now I'm going to simplify. So x squared plus x squared, that's 2x squared. Minus 14x and then plus 49 equals 25. Again, it's a quadratic, so I'm going to make it equal to 0. So subtract 25 from both sides. I end up with 2x squared minus 14x plus 24 equals 0. So now, because they're all divisible by 2, I can divide everything by 2. And I can rewrite this as x squared minus 7x plus 12 equals 0. Factorising this, I get x minus 3, x minus 4 equals 0. And then solving, we have x equals 3 and x equals 4. X equals 4. So I need to find the corresponding y values, and I'm going to use y equals 7 minus x to find them. So if I have the first one, so y equals 7 minus x, so 7 minus 3, which is 4. And the second one, y equals 7 minus 4, which is 3. So my two pairs of solutions are 3, 4 and 4, 3. Here's another example. So x squared plus y squared equals 20 and y minus x equals 4. So I have the same issue as before in that the bottom equation doesn't have either x or y as the subject. So I'm going to start off by making y the subject. So y equals 4 plus x. So now I can plug 4 plus x in for y. So I end up with x squared plus 4 plus x squared equals 20. So x squared plus, I'll write it as x plus 4. So x plus 4 plus times x plus 4 equals 20. So now I need to expand out the bracket. So x squared plus 4x plus 4x plus 16 equals 20. So 2x squared plus 8x plus 16 equals 20. Now I'm going to minus 20 from both sides, so I end up with 2x squared plus 8x minus 4 equals 0. Again, I have the same situation as before in that all of the terms are divisible by 2, so I'm going to divide each of them by 2. So I end up with x squared plus 4x minus 2 equals 0. So now the issue I have here is this thing does not factorise, so I'm just going to have to use the quadratic formula. So I have x equals minus 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a times c, so 1 times minus 2, all over 2. So that's going to be minus 4 plus or minus the square root of 16 plus 8 over 2. So I end up with minus 4 plus or minus the square root of 24 over 2. So if I evaluate those, I get x equals 0.45 and x equals minus 4.45. So now we need to find the corresponding values of y. So if I do that, I end up with y equals 4 plus 0.45. So that one is 4.45. And the bottom one, I get 4 plus minus 4.45. So in this case, I get minus 0.45. So the pair of solutions to this one, so I'm just going to write it over here because I've run out of space. So I'm going to write down 0.45, 4.45 as one pair. And then the other one, I'm going to write as minus 4.45 and minus 0.45. So this is my pair of solutions to this one. So here are some quick fire practice questions on this topic. So pause the video if you want to have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. So here are the answers to these two questions. But yeah, so that's everything for this video. So well done if you managed to have a go at this, and I'll see you again in another video. Bye!